Hello and welcome to an introduction to HCR Air Curtains. In this video we will cover what an air curtain is, how air curtains work, and the components which make up an air curtain. Here we have a basic doorway. The anteroom is the warm side of the opening, and the freezer is obviously the cold side. When a temperature differential exists in an opening, a natural flow-through occurs. Notice at the top of the opening, air is flowing into the freezer, and at the bottom, air is spilling out. At the center, no flow occurs, which results in the neutral pressure line. This flow-through causes several problems, including fog and wet floors on the warm side, frost buildup on the ceiling, and ice on the floors on the cold side, and an increased load to freezer refrigeration equipment. HCR air curtains work by matching the momentum of this natural flow through the opening. The first step is to blow air across the opening at an angle to prevent flow-through. The second step is to condition that air using heat to prevent moisture or frost problems. This heat can be either electric or condenser waste heat. This is what a perfectly adjusted air curtain looks like. Notice the air does not blow across in a straight line, and instead takes a curved shape. You'll learn how to adjust this curve in future videos. This is a computer-aided fluid dynamics or CFD simulation of a perfectly adjusted air curtain. Notice how much more cold side air, the blue air, is spilling out in the left picture. Psychrometric charts, such as this one, are used to tell if and how much heat must be added at an opening. On the x-axis is temperature, while the y-axis the amount of moisture is plotted. This is the saturation curve. When this line is crossed, relative humidity would go above 100%, which is what causes the frost and ice problems in freezers. The blue line here is drawn between a cooler at 34°F and a 75°F anteroom. Since the saturation curve is not crossed, no heat is needed in this application. Between the -10° freezer and a 75° anteroom, the saturation curve is crossed. Therefore, in this application, there would be frost and ice problems, and heat must be used in an air curtain. HCR air curtains are comprised of three main components: top equipment, intake plenum, and discharge plenum. The top equipment often contains the blower assembly. Service calls related to air curtains may require the fan wheel to be inspected. This can be accessed through doors such as this one. The motor is also contained in the blower assembly, and is normally direct drive, although belt drive blowers are still common. Control panels are sometimes mounted within the envelope of the top equipment and coolers only. They cannot drop below about 14 degrees, so if ever a panel is mounted within the freezer, consult the factory right away. The intake plenum is where air is sucked into the air curtain. A screen exists here that needs to be kept free of debris, else air may be restricted. The discharge plenum is where air is blown across the doorway. The nozzle pictured here directs the air in order to match the momentum of the flow through the doorway. You'll learn how to adjust this shape in future videos.